Today we're going to talk about a new concept, and that new concept is ratios. Now, here's the concept of what ratios is all about. I want you to think of ratios as fractions, but what I want you to also think about is that ratios are dealing with a thing called comparison of quantities. So a ratio is literally a comparison of two quantities with the same unit. So now, when we consider this, right, I'm going to give you an example of how we would come up with a ratio. So for example, the ratio of students to computers is 5:1. Now, when you see 5:1, this is really read as 5:1. Okay? This means the following. So remember, 5:1 is the same as saying 5:1 means that there. So this means that 5:1 really means that there's 5 students for every one computer. So now let's talk about this thing called equivalent ratios. Okay, so imagine I have this class, okay? Now, this class of kids has 30 students, and there's exactly 6 computers. So what we would say is the ratio of students to computers is 30:6. So remember, the double quotes represents the word 2. Now, here is what I could tell you about this information. I would tell you that the word equivalent, so we have this new word called equivalent. Equivalent means something is equal or the same, essentially. So you can say the ratio is equivalent. So the ratio of 3:6 is the same as or equivalent to 5:1. Now, your question is, how the heck could that be? Well, they are the same meaning because if you think about it, if I took 30 divided by 6, that's 5, right? So that means there is 5 times as much computers to students. Isn't that the same as saying 5:1? So essentially what we did was, in order to move from this part here to this, is we divided both of these by the number 6. So we divided the first number by 6 and the second number by 6 to get what we call an equivalent fraction. Now, let's talk about how we can come up with these things called equivalent ratios, which is what this statement means. When I say 30:6 is equal to 5:1, these are equivalent ratios. So let's go over how to come up with equivalent ratios. So here are ways to come up with equivalent ratios. There is one where we can multiply to find a new equivalent ratio. So for example, here is what we're going to do. So imagine I tell you we are going to use multiplication to create a new ratio. So for example, if I had 8 to 10, right? What we can do is we can write this as 8. I put a colon, I put a space, and then I put 10 beside it. Now, I just choose a number. Let's choose the number 3. Let's multiply everything by 3. So we're going to have 8 times 3 and 10 times 3. Now, 8 times 3 gives us 24. And then we still write our 2, 10 times 3, which gives us 30. So you can say that 8 to 10 is equal to 20 to 24, or this 8 to 10 is equivalent to 24 to 30. Now, another way to do this is by division. So for the division, what we're going to do is we're going to divide each term by the same number. In this case, let's say I had 8 to 10. 8 to 10. So what we can do is we can write 8 and 10. And then what we do is we divide both of these by, say, like if I look at 8 and 10, both of them can be divided by 2. So we'll divide both of those by 2. So 8 divided by 2 gives us 4. And the other, so we have 4. And then 10 divided by 2 gives us 5. So we can say that 8 to 10 is equivalent to 4 to 5. And we are literally done for both of these. So you can either multiply both of those by the same number or divide both of those terms by the same number. That is what an equivalent ratio is all about. So the last thing I want to remind you is this. When we're dealing with mathematics, we sometimes have to deal with these things called ratios, okay? Now, sometimes we want to make sure that we have the lowest ratio. So let's say I have something like this, 30 to 10, and I want you to come up with the lowest ratio. The key idea is to look by the lowest number and divide by that lowest number. So in this case, we're going to divide both of these by 10. So we can come up with an equivalent ratio of 30 divided by 10 to 10 divided by 10. And that will tell us that when we have 30 divided by 10, punch that in your calculator, you get 3 to 10 divided by 10 gives us 1. So we know that our ratio is 3 to 1 for this. So here's another problem. So let's go and take a look at, say, 48 to 24. You can either divide by some number other than 24, but you know what? I'm going to use 24. You could use 2, 3, and 5, doesn't matter. But I choose to try to use 24 to divide them out to make these numbers come out nicely. So if I divide 48, I notice when I divide 48 by 24, we get a nice number. And we write our colon, and we go 24 divided by 24, which gives us a nice ratio of 2 to 24 divided by 24 is 1. And there is our answer here, and there is our answer here. So what we can do is we can use this to make our lives easier and decide, say, which is the better deal, right? It's very similar to what we studied a long time ago when we studied unit price. This is just an alternate version of what we would call the unit price from previous classes. So if I was looking at this, I could say that if I was looking at these two ratios, or I was looking at, say, the win percentages of different teams, I could say that the top The top ratio, 30 to 10, is making more than the bottom ratio that gives us a ratio of 2 to 1.